Today I'm going to be talking about modular synthesis, which was really the first form of electronic music that wasn't just sort of a one-off device. There were some very early things like the theremin, but really the first synthesizers that could make lots of different complex sounds started with modular synthesis, and it kind of grew out of test equipment where you had, voltage-controlled oscillators that could do different sine waves and square waves, and you had different electronic filters that you could adjust, and people started putting these together and doing things in the audio spectrum. So that was sort of the beginning of synthesis, and over time, it's evolved quite a bit. So let's start off saying, what's interesting about modular synthesis today? Obviously, we can do all kinds of things in the digital domain. There's amazing analog and digital, synthesizers you can buy that aren't modular. But why do we want to think about modular today, even with modern technology? And it's the open architecture aspect of modular. It allows the module designer a lot of creativity to do something that they don't even know how other people are going to use it. The person who's building their synth can select from different modules from multiple manufacturers, and you can even build your own. You could build your own synth, but it's a lot easier to just build your own module. There's a lot of DIY kits out there. Actually, there's the biggest DIY store. It's in the United States that I know of is actually in Bedford, Massachusetts. It's called SynthCube. And they used to just do an online business, and then they opened their store a few months before COVID hit. But you can go to synthcube.com and look at all the DIY kits they have. The interesting thing is, you can build a synthesizer for the kind of music you are interested in. You can build a flexible synthesizer, or people build multiple synthesizers. They'll build something just for ambient. They'll have something different that they use for techno. It's the huge amount of flexibility that you get from building a modular synth. So let's just take a step back for a second here, and when we're talking about synthesizing sound, what are the fundamentals? And in order to understand the different parts of a modular synth, you kind of have to understand the fundamentals. On the left here is different waveforms that you see from different instruments, musical instruments, like the flute on the top, middle C on the flute. Graph shows it's almost a perfect sine wave, right? So you're just getting, one thing vibrating, no harmonics, very pure sound comes from the flute. And if you look at the sound spectrum over on the right, the sound spectrum of middle C played on the flute, you'll see that you're just getting one pure sine wave at 262 hertz. Then if we look at other instruments like the piano, we see the piano, since it's a stringed instrument, you're automatically going to get different harmonics on the string. You're getting reverberation in the case of the piano itself, and you'll see that the piano has a harmonic at twice the bass note. So if you play middle C on the piano, you'll see a harmonic there, and then some even a third order and fourth order harmonics that give it certain character. And you can see in the waveform it's different. So people call this timbre or voice or quality. There's a lot of technical terms to it, but basically when you play notes on different instruments, because of the different harmonics, they give a different sound. And you can see the trumpet. You got all kinds of different harmonics coming out of the trumpet. It's interesting that the second order harmonic on the trumpet is actually higher. You see the first order at 262 hertz, and the second order at 525 is actually louder. So it's interesting that the has a trumpet obviously has a very distinctive sound, and then mixing these things together, a flute, a trumpet, and a piano, they can all be playing the same note, and you get some nice complex sound, even if they're all playing the same note together. And that's what we're going to be doing with the synthesizers. We're going to be creating different waveforms, and you can have 3 VCOs going at the same time, 3 voltage controlled oscillators, and you'll get a more complex sound than if you were just playing one of them. So let me switch for a second to sharing my entire screen here. And you should see, you'll see my voice going, but I have Ableton Live going here, which is a digital audio workstation. And you can see my voice both as an oscilloscope and as the spectrum. Now, when I play a note on the synth, like I'll play middle C on the synth, we'll see a simple sine wave. So you can see that middle C is giving us around 262 hertz. And you can see there's a couple of harmonics there. It's not a pure sine wave, but it looks pretty close on there. So, all right, now I'm going to go back to the presentation. Okay, so just some of the fundamentals here before we go into the pieces of a modular synth is there's different formats. In the picture is an older Moog 5U format, and if anyone's racked equipment in a standard rack, you understand 1U, 2U, 3U, 4U. It's standard height. And since all this came out of test equipment, rack mount was the standard that everything was built on. And so the first hardware formats were bigger because components were bigger. We've gotten much better at making smaller and smaller components. And you can see that, so we got a lot of height there at a 5U, and these are also very deep. The circuit boards went sort of perpendicular to the front panel, and so that you can have a lot of big components on them. So the very first in the 70s came out. The Buchla was one of the first synths in the 70s. Came out with a 4U format, and the Moog, which probably everyone has heard of Moog. They had much more commercial success than Buchla. Because Bob Moog really made his instrument to sell to musicians of the days. So a lot of the synth music you hear from Pink Floyd and a lot of the bands in the 70s were Moogs. But over time, what happened was digital technology kept improving, and in the 80s we started to get digital synths, which were making sounds with digital circuits, and sampling was big. So why not just sample the flute and play back the sample of the flute rather than trying to create the flute using an analog circuit? And that gave a different character to the sound. And in the 80s and early 90s, digital kind of took over. But then in '95, this company, Doepfer, in Germany, came up with a new, more modern designed modular system, and they made it in 3U so that you could fit you could use smaller size modules, and they came out with this in '95, and it's really kind of exploded since '95 in the intervening 25 years, but really in the last, I would say, 10 years, it's exploded even more. There's over 100 manufacturers making these modules, and that's up here on the top. This is a Eurorack, and you can see it's 3U, and this is sort of a standard 19-inch rack wide case I have it in. And here's an example of a module that's not in the case. This is a little sequencer, and this is the power cable. But then all the other, it's just power on the back. All the connections are on the front, and they're done with these patch cables. So when people say, you know, they're patching a sound, even in the digital realm or even in software synths, what this all comes down to is we used to patch things by plugging one module into another, either audio or control voltage. And I'm going to talk about that. The other thing that I have here is this is a Behringer Neutron and a Behringer Model D, which is a clone of the Moog, Mini Moog, which was one of the most popular Moog synths. And these are called semi-modular because you can see that there's a lot of parts of the synth that don't have inputs and outputs to them, but there's some that do. And so you can actually patch these to make different sounds that aren't internally wired in the synth. So like here, we have the oscillator bank is internally wired to the mixer, is internally wired to the filter, and then to the output. Whereas up in the modular, none of this stuff is connected underneath. I have to connect it on the front. So nothing happens with a modular until you connect it. With a semi-modular, it's already internally wired, but you can override by patching into this. So, you know, I could, you know, take the LFO out, low frequency oscillator out, and I could vary the frequency of the filter with the low frequency oscillator so that I would get like a tremolo sound, and I'll give an example of that later. But so you can modify and add to it. The other thing, and this is probably the most important thing, is it's Eurorack compatible, right? So if I can patch this semi-modular synth to this semi-modular synth, and then into the fully modular. So by making it semi-modular, what these manufacturers have done is they've made it so it's expandable. But it's a good entry level, and this is actually how I started, because it can be kind of daunting to just start having to build patches before you get any sound out of the synth. The other thing is interesting is there's fully software modular. So it's an open source project called BCV Rack, and it has all the basic modular modules and actually name branded modules. So like some of these modules I have here, like this mutable instruments marbles or the ripples filter, there's actually versions of those in software that emulate them completely in software. So software is a great way to learn, and it's super inexpensive because most of the modules are free or they're very low cost. You know, some of these modules will cost, typical module costs like $150, $200. Luckily, resale is really good, so if you don't like it, you can resell it. But it can get quite expensive. These semi-modulars, especially these ones from Behringer, are very inexpensive. Like you can get in for like under $300 into one of these and make a lot of music. The other cool thing about the software modular is you can actually connect it into your regular modular. So you can actually get USB to CV outputs, and you can connect them together. So you could have a modular and say, hey, I want to try out this new module in software, and you can connect it in with your hardware and play with it. But you might be saying, well, why doesn't everyone just do software? Why do people, do the hardware? And for one thing, with analog circuits, and it definitely, the software version is really good, but you can hear the difference, the pure analog circuit. But the most important reason is you don't need a computer to make music. And so I think people who hang out on the computer all day, it's kind of nice to be able to make electronic music without having to do it on the computer. And here I can just use my keyboard, my sequencer, and I can patch and do knobs, just turn knobs, and have nothing to do with the computer. So the basics of how the modular works, and this is internal on any synth, is the pitch is determined by a voltage. So and the standard for Eurorack is 1 volt per octave. So if I send 1 volt to the VCO, I'm going to get a middle C. And if I send 2 volts to the VCO, I'm going to get 1 octave higher. And so this allows me to control the pitch that's playing in the VCO with a control voltage, and that can be infinitely variable. It's analog, so it's infinitely variable. Can obviously change to another voltage at nearly instantaneously. So we can do very complex things by controlling with voltage. Pitch voltage is kind of a special version of seat control voltage, because it means something. 1 volt means basically a middle C. But control voltage is used throughout the modular to control other parts. So a voltage-controlled filter is controlled by a control voltage, and in the semi-modular, I'm controlling that with a knob. Actually, I just showed you that it actually has a cutoff frequency, has a input on this, because that's a very important thing to be able to change. Another example is a voltage-controlled amplifier, which is the loudness of the sound. So I can change whether something is loud and then fading out by changing the control voltage to the VCA. And this is the way that we can get, is it a loud note, a quiet note? Is it sustained for a while? Is it going away? And that's all done with control voltage. Some other kinds of control voltages are gates and triggers. So a gate might be a key getting pressed down. So I press a key down, control voltage comes out at 5 volts. And when I let go of the key, it goes back down to 0. So that could be turning an oscillator on and off. So that I could be playing a note. A trigger might just be at the beginning of when I press the key, you might send a trigger, or you might have a clock that is sending a trigger signal every once in a while and getting something to synchronize, something like that. So those are how we are controlling things with voltage. The next thing to talk about is the different building blocks. So audio sources, control voltage sources, audio modifiers, and control voltage modifiers. There's a great book called Patch and Tweak, and they didn't invent using these symbols, but they use these symbols throughout the book, and it makes it really easy to understand kind of what's going on. In the interest of time, I'm just going to go through audio sources, control voltage sources, and audio modifiers. Control voltage modifiers is yet another level of complexity that you can have. So here's some audio sources. Let me share the screen again so we can see what I'm playing here. So I'm going to play some different notes here. So this is the sine wave. I'm actually faking the sine wave by just using my filter to cut off the high frequencies of a triangle wave. So here's a triangle wave wide open. You can see the character is different because I'm getting all these even harmonics. If I switch to the square wave, it's a little loud. I'm getting even harmonics, and then the sawtooth, you're going to see, because it has even and odd, it has even more of a sort of dirty character. See all those harmonics. And then you can also have random wave, which is kind of just noise. And there's different kinds of noise and different kinds of randomness, but I don't have a random VCO easily accessible. So those are the sources of audio. And then we're going to take that and then we can modify it, as I was saying, with voltage controlled filters and voltage controlled amplifiers. So here is an example of a high pass filter. I'm going to put the mic down here so I can use two hands. So you can see the filter, as we modify that, really changes the timbre of what's going on. It kind of smooths out that wave towards a sine wave. And then we do the other way, a low pass filter. I'm sorry, that was a low pass filter. This is the high pass filter. And you can see that with that high pass filter, we're getting rid of the fundamental and we're just hearing the overtones. And so we can just, you can design crazy filters, band pass, low pass, high pass. In software, you can, it's infinitely tangible. But you can just do this simply in analog. And the VCA is an example of, changing how loud something is. So a good example of that is, when you hit a key on a keyboard, it sustains over time and kind of fades away, right, as the note decays. A VCA can simulate that by, lowering the amplitude over time. Let's see, let's just go back to the presentation. So here, other important building block is modulation sources. So a modulation source is something that is another waveform that is not audio, that is can control, say the loudness so this is something you might feed into a VCA, an envelope generator, to feed into the VCA to give it that sustain, rise, attack, they call that attack, and then release at the end of a key. So like when you hit a key hard, you might want it to actually kind of spike there. If you can see in this second ADSR, when you hit the key, you might actually, it might get loud for a second and then fade away over time. And so we can replicate all kinds of things like drums getting hit and piano and, plucking of strings, all these different kinds of things with a different kind of envelope over the sound. Low frequency, and so I'm gonna show you that. Low frequency oscillator is something where it's sort of like a VCO, but it's typically below the audio range, like maybe 100 hertz. Well, that's at very low audio, but typically you could get down to like a 10 hertz, which you could never hear. But that sine wave at 10 hertz can be fed into something like the cutoff frequency of the of the filter, or into the VCO, and that can give it a warbling effect. Let me show you that. So I'm going to turn up an LFO here. And so that's feeding an LFO into the oscillator. So we're getting some different sounds. So basically, you got all these building blocks, and you can combine them together to make something arbitrarily complex. And if you've ever seen pictures of modulars, you could actually have, easily have 100 modules wired up with 500 cables, and make arbitrarily complex sounds out of these basic building blocks, sort of like making software out of open source libraries. So let's do a patch. So let's see here. I'm going to zoom in on the modular, so we can do a patch. So just bear with me for a second. Hopefully that's in focus. I'm trying to make it big so I can focus it. Let me stop sharing my screen for a second. Okay. Oh, that looks pretty in focus. Okay. So now we're going to do a patch. So let's get the screen share going again. Okay. So one of the cool things about the patch and tweak book is they actually have a patch editor online, and they have a lot of patches pre-built for VRAC, so you can actually just learn from what they have online if you don't even want to buy the book. But the book is a really nice reference manual, and also has some great stories from different artists. So so let's go through. Let's do a patch here. So I'm going to start with the yellow cables, and I don't have all the right colors for this, but I have some of them. So we're going to start by saying, okay, my keyboard is actually has CV out directly, but I have that CV of the keyboard coming out of here. So I'm going to patch that CV out, which is going to be my pitch, into VCO. They call it tune here in chip 1, but it should just be, they should just call it volt per octave in, like this one does, and call it, VCO 1. And then we're going to take the output of that, and we're going to, let's see, it goes into a low-pass filter. So we'll take the output of that VCO, and we'll put it into the input. This is a filter, and it has bandpass and low pass ability. So we'll then take the low pass out, and we'll put it into a VCA I have here. Right here. And right here. And okay, so now we have the audio chain. Oh, I need one more. I need the output to go in, and I'm putting it into this module here because this module, I'll talk about a little later, is called a granular processor, but it's what's wired to my mixer, so we're just going to run it through there. Okay, so that's the audio chain that's in the yellow up above. Now we're going to do the control voltages to control the audio. So the red is a gate CV. So I'm going to take the gate out of the keyboard. That's going to tell me. So the oh, I did something wrong here. I was supposed to use gray for this one. I guess we can use yellow here. So yeah, the pitch is in gray. So that's pitch, because it's a special kind of, oh, my little dinosaurs. It's a special kind of control voltage. All right, so we got the pitch going into there. Now the gate comes out of the keyboard. So the pitch is which key is pressed, and the gate is like when it's pressed down. And that goes into the envelope generator. So this is my envelope generator here. And what else comes out of the, okay, so I'm not going to do the other CV out of the keyboard, which is, I think, is velocity. So every time I hit the key, whether I hit it hard or hit it soft, we're going to get the same sound. If I had added velocity in, it could change the envelope, but I haven't quite figured that out yet. So let's see. So now we take out of the envelope generator, and we're going to go into the filter and the low pass. The low pass filter and the VCA both get the CV output of the envelope generator. So I'm going to use a splitter here. So I'm going to take the output of the okay, so I split it. So I took the output of the envelope generator. I'm using the exact same envelope to vary the frequency of the filter and vary the loudness. So by varying the frequency, I get a little bit of a more realistic instrument sound, because in the real world, as things resonate, there's some sort of the frequency changes a little bit. So let's try this. Oh, no, that's the wrong synth. Okay. So I have to. So that's the sound we're getting that I just patched up. And I'll show you that by, I can change the attack here to be fast. It's a little snappier in the beginning there. And this is back. So we can change the envelope to rise faster, and this is, we can make it fall off slower. And that envelope is really changing the filter too. You can hear. So we're not only changing the loudness, we're changing the filter with my gate. Let's just do a chord here so I don't have to keep hitting the keyboard. We'll do a ARP here. And I can vary the filter. Should be showing the whole screen here so I can see. Very attack and decay. So that's a basic patch, and we can kind of control the sound of that. So let's stop that. And we'll go back. Okay. So that's a basic patch. So we obviously want to get more complex than that. I mean, we can definitely make music with that by sequencing and having different notes. But the beauty of the modular is we can just add on to that patch and add a lot of complexity to it. So this is an example of a when we want to do pitch and gate inputs. Let me just see here for a second. When we want to do pitch and gate inputs, typically you're using a MIDI keyboard or a MIDI sequencer. That's what I was using. And this keyboard has sequencing built in. I can record all kinds of different sequences. It has arpeggios built in, so by holding down different keys, I can just do different arpeggios. And that's nice, and I can just you can perform, right? So like live, you can actually just play the keyboard. MIDI sequencer, which I have over here, this circuit is a really inexpensive sequencer that you can play with that I am also just learning. But it has MIDI out, so I could load up sequences into that, play sequences on here, and do things that way. A lot of people don't want to have anything outboard of their modular. They just want to have their modular in a travel case and just go with just that one piece of equipment and just plug into some mixer. And they want their sequencer to be on the modular unit. This is a very simple sequencer, and it's actually a performance controller. You can push these buttons to play it. But sequencers, there's very complex modular sequencers that you can use to play different series of pitch and gates. The other thing that's interesting is we don't need to use a keyboard or a sequencer. We can take pitch and gate inputs from random number generation. So a random circuit, a random analog circuit can give me pitch and gate information. So I have the Marbles random sampler, and basically it has a random number generator, and it samples that random number and modifies it in different ways, so that you're not just getting sort of pure noise. You can adjust the rate, the jitter, the length that things repeat. You can quantize it with the steps, and so instead of getting a purely random number, you can actually have it quantized, so it always falls in a typical chord sequence, pitch sequence that you would get out of a keyboard. And so that's an interesting thing that I play with a lot, because I like to make kind of that ambient sound, and you can certainly do ambient with playing the keyboard or building a sequence, but you can do the exact same thing with random pitch and gates. So that's an interesting thing that I've added on to add some complexity to the music generating process. Another module that I have is is a granular synthesis module. Um, Mutable Instruments um, calls it a texture synthesizer. But the interesting thing about granular synthesis is it samples the input, but it takes tiny chunks of that input and splits it into small pieces from 1 to 50 milliseconds, and then can play those back at different volumes, different phases, different frequencies, and you can modify this with the knobs, but you can also modify this with these different inputs. So those knobs up above in the picture, there's also CV inputs. So like say the density of the grains of sample you're going to be playing back, you can vary that with the knob, or you can just vary it with CV. So you could have an LFO, for instance, you know, make it change over time, and that's really a lot of the beauty of modular, is the infinite flexibility by using CV inputs to change all of these things. The this microcell granular processor is a clone of the clouds from Mutable Instruments. Mutable Instruments discontinued clouds a few years ago, but one of the cool things about Mutable Instruments, and one of the reasons I support them, I have a couple other modules, is they're fully open source. So not only is the firmware open source, you can change your clouds that you bought from them, and people have multiple firmwares out there to do different things. But the hardware is open source. So this is an open source hardware that actually has more controls than the original cloud and has 4 different firmwares I can choose from. And it's incredibly complex. I mean, I've had this for maybe 6 months, and I've probably tapped 5% of it. These things can be incredibly complex to learn. But it's a lot of fun when you're doing things like ambient, because it has reverb, it has feedback, and it has the granular synthesis built in. So that's sort of the survey of the modules that I have. Actually, I have a couple more. I have a low pass gate here, which is similar to a low pass filter, but it's designed to be triggered, and it changes over time. And then I have this other module, which actually is it's a digital module, and it has about 40 different things it can be. So I have it set up to be a wave folder, which is a very interesting sound where you can fold, say, the sine wave back on top of itself. And I mostly use it for that. But there's dozens of different modules you can get. Here are some examples. FM synthesis. Actually, I have an FM synthesis on one of my VCOs. Samplers, physical modelers, where you actually can design the instrument like a drum by saying, like, well, this is the width of the drum, and this is the depth of the drum, and this is the tightness of it, and it's all done in the analog. Tape feedback, sample and hold. Turing machines are another form of sequencer, or you can put randomness, and you can have mathematical sequences. And then sort of that on the right-hand side at the end there, pressure and area sensors, sliders and joysticks, ribbon controllers. These are all performance inputs where you can change CV by using a joystick, for instance. So the picture on the left, the planar by IntelliGel, that joystick allows you to change 2 CVs at the same time. So instead of a slider just going in one direction, you can change 2 CVs at a time and have sort of a 2-dimensional CV1 and CV2 to change 2 different things. So maybe you want to you want to change your bit crusher, changing things at the same time that you're you're changing your feedback. all kinds of different things you can do to make an interesting performance. I think the planer allows you to record and play back your movements on the joystick too. Okay, so that was sort of what I wanted to get through on the overview. Now I'm going to plug in some of these other modules, and we're going to see if we can make something that is maybe a little bit like an ambient music. Oop, I'm hitting my tripod here. Okay, so let's see. So what I'm going to do is I'm going to switch to, I'm not going to use, I'm not going to use the keyboard. To trigger things, I'm going to use let's see. I'm going to use the Marbles random sequencer. So on the left here, you can see these lights are blinking randomly. The T's are gates, so I can plug in this, and I'm getting a gate signal whenever that light blinks, and that's going into my envelope generator. But we obviously want pitch. I'm going to use this plates. This is actually another clone of Immutable Instruments. One of the nice things about some of the clones is over time people figure out how to make them smaller. And there's a debate. These knobs are not as easy to get precise as these bigger knobs. It depends if you're doing a lot of performance or not. If you're changing a lot of knobs in a performance, then you're going to want to have better knobs. But we're going to do the output of this. No, we're already getting some sound here. So that's just what that oscillator was tuned to when the circuit came up, and we're getting random gates are going out. So that's just some randomness. Now I'm going to take the output of some randomness over here. The X 1, 2, and 3s are 3 different quantized random signals that are good for doing volt per octave, so pitch control. So now I'm getting random tones, random pitch, as well as random gates. And then what I can do is I can take my granular processor, and we can start to, first of all, if we're doing ambient, we have to turn up the reverb, right? We want to be spacey. So that's just turning up the reverb. But then we can start to get some granular chunks in here. You can quickly get out of control with it, just overloading it. We can change the character of the envelope here, make it more plucky. We can go faster. We probably want to go slow with ambient. And just to show you that we can kind of just arbitrarily change things, I have an LFO here. And so the output of that LFO, I can put into the model of this VCO. This VCO has like 8 different models of sounds it can make. And I can just switch. So I can just randomly switch between the different models. Making music around here. So, seems like I got some sort of bell going on there. All right, well, I think that was pretty much all I had to show. Let's turn that down. I wouldn't say that's very chill sounding. But hopefully everyone enjoyed that. I think we have, I don't know, we got about 7 more minutes. So if there's any questions, I'm happy to answer some questions. You could either unmute or type it in the chat, whichever you like. Dogs across the state are losing their minds. Yeah, a lot of ambient sounds like whales. All right, well, if there are no questions, thank you for coming, and I hope I kind of spurred your interest a little bit into how synthesizers work. And everyone have a great hackathon. Bye-bye, everyone.